Day 87 of doing a LeetCode problem every day until I get a job. All right, guys, we're back again. Another day, another LeetCode problem. This time we're at day 87. We're really making some progress here. We're almost 3 months in, guys. So I hope you guys are staying with me and you guys are not feeling any type of burnout or lack of discipline or lack of motivation because we're just getting started. But before we start today, don't forget, guys, bring a mouse right over here and click that subscribe button for me, guys. Then after you click that subscribe button, go ahead and smash that like button for me, guys. Then after you smash that like button, I'm calling all of my bankers. I repeat, all of my bankers to the comment section. I need you to drop 2 bank emojis in the comment section so we can run up this engagement and we could get this content out to a broader audience and get more people interested in learning Swift as a whole, and we could do our part and help building this Swift community, guys. Now, with that being said, I know why you're here, and today we have question number 452, minimum numbers of arrows to burst balloons. The difficulty level is medium, but you already know how we do. We're going to keep the solution as simple and easy to understand as possible because we're all learning here and we're all trying to gain some knowledge, and there's no point in writing code that nobody's going to understand. And that goes for when you're just learning how to code or if you're on the job. So let's see what this question says. It says there are some spherical balloons taped onto a flat wall that represents the XY plane. The balloons are represented as a 2D integer array points where points I equals X start and XN denotes a balloon whose horizontal diameter stretches between X start and XN. You do not know the exact Y coordinates of the balloons. Arrows can be shot up directly vertically in the positive y direction from different points along the x-axis. A balloon with x start and x end is burst by an arrow shot at x if x start is less than or equal to x and x is less than or equal to x end. There is no limit to the number of arrows that can be shot. A shot arrow keeps traveling up infinitely, bursting any balloons in its path. Given the array points, return the minimum numbers of arrows that must be shot to burst all the balloons. So let's look at the example so we can see what they're talking about. We have inputs. We have a inputs point that's a 2D array of our intervals. We have 10, 10, an interval of 10 and 16, another one of 2 and 8, another one of 1 and 6, and another one of 7 and 12. The output is 2. The explanation says the balloons can be burst by 2 arrows. Shoot an arrow at x6, bursting the balloons at 2, 8, and 1, 6, and shoot an arrow at x equals 11, bursting the balloons at 10, 16, and 7, 12. So let's break this down and see what they mean. But basically, we have balloons, or we have some intervals, and we could shoot arrows, and the arrows will keep going up infinitely. So which means if 2 intervals are overlapping each other like we dealt with yesterday, then that will take out 2 balloons with 1 arrow, right? So in this case, the output is 2, meaning we only needed 2 arrows. So let's break this down so we can make it make sense. But let's say these are the intervals, right? Excuse the this should be about right here, right? So say these are the intervals right here, right? If we shoot an arrow right here, this gonna get rid of both of those right there. Boom, those 2 intervals are gone. Then we shoot another arrow right here, that's going to get rid of both of these, and both of those arrows are gone. And now we only needed 2 arrows to burst all of those balloons. You know what I'm saying? So that's how that would work. And now let's look at example 2 so to make a little bit more sense and bring it home. So in example 2, we have an input of points, which are the intervals. In this case, we have interval 1, 2, then we have 3, 4, 5, 6, and 7, 8. The output is 4. Explanation says 1 arrow needs to be shot for each balloon for a total of 4 arrows. So if you look at these intervals, none of them are overlapping, which means we're going to need a separate arrow for each balloon because none of the balloons are overlapping each other. So this would look something like this. Then we go 2 here, kind of like what we did yesterday. Then we then this would go from 2 to 3, then we go here. This will go from 3 to 4, then we go here, and this will go from 4 to 5, right? Or, yeah, from 4 to 5. Or, excuse me, no, because it goes, yeah, so then that will go, we go 1 to 2, no, so then we don't go 2 to, we go 3 to 4, right? Then, yeah, so this one be 4 to 5, we come down here, and we go right here, and this will be 5 to 6, then we come down here, and then we have this. Ignore these right now. I'm gonna clean it up so to make it make sense. But hold on, then we go 7 to 8. But there is no 6 to 7, so we could delete that. And there is no, let me see, we got the 3, 4. There is no 4 and 5, so we could delete that too. So if you look at this example, we're in example 2 right here. These are the intervals. We have the 1 and the 2 right here. Boom. Then we had the 3 and the 4 right here. Then we had the 5 and the 6 right here. And we had the 7 and the 8 right here. And if you pay attention, none of these are overlapping. None of these intervals are overlapping. So we need one arrow for this, that one will be gone. Then we need another arrow for this, that'll be gone. Then we need a third arrow for this, that'll be gone. That'll be gone. And then we need a fourth arrow for this, and that, and that will be gone. And all together, it would take 4 arrows to delete all 4 of these, or to burst all 4 of these balloons, or delete all 4 of these intervals, because none of them are overlapping. So if we look at this one, we might as well do the last one. Why not? Since it's right here. So right, we'd have 1, then we had the 1, 2, boom. We had the 1, 2. Then we would have the 2, 3. Then we would have the, we would have the 3, 4. Then we would have the 4, 5 right here, right? So in this case, we only need 2 arrows because the balloons can be burst by 2 arrows, right? So shoot an arrow at X2, burst in 1, 2, and 1, 3, right? So we shoot at 2, boom, we burst in both those right there. They burst, boom. Then we shoot an arrow at X. Then we shoot an arrow at X equals 4, burst in the 3, 4, and 4, 5. So we shoot an arrow right here, boom. At the 4, boom, add delete both of those right there. And now all the balloons will have been deleted with 2 arrows in example 3. So that's more of a visual representation of what we're trying to do. And now that we understand what it is that we're trying to do, now it's time to get into the fun part, the part you're all been waiting for, the code. And the code's not that difficult, guys, at all, really. So the first thing we're going to do is we're going to say let points equal, points dot sorted. Then we're going to say sorted. It's going to be sorted by, and we're going to open up the brackets. We're going to say $, $0, and then we're going to open up the array brackets, put a 1 right there. Then we're going to come over here, put less than, and over here we're going to put another $, but this time we're putting $1, and we're opening up the array brackets, and we're putting a 1 inside right there. Then after we do that, we're going to come down here, and we are going to declare a variable called end, and that is going to be equal to points 0 and 1, right? So we're going to open up the array brackets, put 0. We're going to come over here and put 1, right? So that's how we're going to start with our initial interval. Then we're going to come down here and we're going to declare another variable called arrows, and we're going to set that equal to 1 because we're going to need at least 1 arrow to pop a balloon, right? We can't pop any balloons with 0 arrows. We're going to need at least 1. So then we're going to come down here and we are going to say for point n points, what we are going to do is we're going to say if point 0 is less than, is greater than end, then we are going to come over here, we're going to say arrows plus equals 1, because And then we're going to come down here and we're going to increment the point, and then we're going to say n equals 0.1. Then we're going to do it again for the next one. You know how for loop goes. Then we're going to come down here and we are just going to say return arrows. And that's all she wrote, guys. Not too difficult, not too much code, easy to understand. And look at that, it's accepted, guys. So let's submit it and see how it runs. See what that time is looking like. Hopefully that time is looking good as well. And there it is. We have 729 milliseconds, beat 66.04% of users with Swift, guys. That's what I'm talking about. That's what I like to see. Then the memory, the performance is looking good as well. 25.22 megabytes and beats 90.57% of users with Swift, guys. So it's not too bad at all. Get one more look at the code, before we go. And I will see you guys tomorrow for another day, another LeetCode problem. Peace.